So let us begin our first lecture with the introduction to Vedic mathematics. So as the word itself suggests, Vedic, it has come from Vedas. So Ved is a Sanskrit word which amounts to the fountainhead of the knowledge on everything. Now, Ved, it's a Sanskrit word which has come from the Sanskrit word Ved, means knowledge, and thus the Vedic mathematics, it means Rishis, sages are our real scientists and technologists. Some of the Rishis, so to say, are Kaushik, Atri, Vasisht, Vishwamitra, Jamadagni and so on. They, under the deep meditation, they acquired the knowledge of various subjects from cosmos. And whatever knowledge they acquired, they passed on to their disciples. So it was a teacher and student, passing the knowledge from teacher to the student. Those disciples, they had their students and they passed on the knowledge. And hence, the passing of knowledge from teacher to student. So it is the custom of passing the knowledge from teachers to student. It is known as Guru Shishya Parampara. Which still exists till the present age. And the Gurukula Parampara, which is the staying with the teachers for so many years till they acquire or till they get the complete knowledge, and this system is almost abandoned at present. So the Guru Shishya Parampara, it is being continued, and earlier this knowledge was transferred from brain to brain, and brain is the main storehouse of our system, and this knowledge was later on available in the form of, so the Sanskrit is the oldest language on the earth, and this Sanskrit language, the Vedas were in the Sanskrit language, and there were mainly 4 Vedas: Rigveda, Yajurveda, Samaveda and Atharvaveda, followed by 4 sub-Vedas, or they are known as Upavedas. And these Upavedas are, first is Ayurveda, pertaining to medicinal aspects; Gandharva Veda, pertaining to music, art, dance, etc. Dhanurveda, pertaining to archery and military science; and Sthapatya Veda, containing the engineering aspects. So to acquire the knowledge how to utilize this knowledge of Vedas, there were 6 Vedangas, or what is known as limbs, to understand how to frame the sentences, how to make poetic form or shlok form, and how to use a proper knowledge, grammar, etc. So 6 Vedangas were there, along with 4 Vedas, 4 sub-Vedas. So this knowledge was available to the mankind in the Sanskrit language, and Of this entire knowledge, Vedic mathematics forms a tiny part of whatever is present in Vedas. So the mathematics or Vedic mathematics, it is a link between man and nature, and also it is a life and death cycle of a body. So life begins with the heartbeats, so the counting starts and it stops at the time of death. Whereas whatever is surrounding man is nature, say air, water, earth, plants, animals, planets, stars, galaxies, and so on. So everywhere when there is a link between the particular, whether it is air or water or earth, plants, animals, planets, etc., there we get mathematics. So as far as mathematics is concerned, the several mathematicians were there since long, thousands of years, and to name a few mathematicians who were astronomers also, astrologers also, some of the names are Panini, Pingala, Bodhayana, Katyayana, Aryabhatta, Varahamihir, Brahmagupta, Bhaskaracharya I, Bhaskaracharya II, and so on. The list goes on and on. And later on, in the 20th century, directly we are jumping to the 20th century, and the earlier mathematicians, the names which I had given, their literature is available now also. 20th century also there were hundreds of mathematicians like Ganesh Prasad, Dattatreya Kaprekar, Jayant Narlikar, and so on, but we are interested in only two mathematicians. One is Srinivas Ramanujam and Swami Bharati Krishna Tirtha. Srinivas Ramanujam, his lifespan was hardly 32-33 years, and Swami Bharati Krishna Tirtha about 75 years. But in only 32 years, Srinivas Ramanujam has shown what a genius mathematician is. So of the 32 years till matriculation, even if you subtract some 14-15 years, within next 15 years he produced almost 4,000 treatises, equations, etc. on pure, and just you can imagine, he was interested only in mathematics and not in any other subject. So that's why after matriculation he could not complete the graduation degree, but he received a PhD and a fellow of Royal Society, and of his inventions of 400 treatises, etc., hundreds of mathematicians have received PhD. So that is the greatness of Srinivas Ramanujam. As against Ramanujam, Swami Bharati Krishna Tirtha, he has a lifespan of almost 75 years, and he always stood first in his class right from the first standard till he completed MA degree. In matriculation itself, he has completed the highest exam in Sanskrit, and he awarded a title called Saraswati by that time's Madras Sanskrit Association. Later on, he appeared for MA degree in 7 subjects. So just if you see 1884 onwards till MA, means roughly 1902-3 year, when we were under the Britishers rule. At time there was no university in India. One has to appear from foreign university, and centers were there, 4-5 centers like Madras, Bombay, Delhi, Calcutta, etc. And he appeared in a single academic year. He took the special permission to appear for MA degree in 7 subjects, and in a single academic year he completed 7 MA degrees, and all in first rank. That is still a world record. So after completion of master's degree, he served for some few years as a principal in the Rajamahendri College, and later on he took sannyasa diksha, and under the deep meditation at Sringeri Math in Karnataka for about 7 years, he studied and found that the Atharva Veda shlokas or verses, they have the hidden mathematical meaning, and from Atharva Veda as well as from the study of Sthapatya Veda, where mostly the mathematical part was there, he could concise it in only 16 main formulae and similar sub-formulae. So it was the reconstruction of ancient Indian traditional mathematics, which takes us back thousands of years to the Vedic periods in the form of 16 main sutra, and they form appendix or parishishta of Atharva Veda. Hence the 16 main sutra, that is our basis of what is known as Vedic mathematics. So the Vedic mathematics is the name given by Swamiji wherever we use these sutras to get the answer in a step or two. The mathematics of Vedic mathematics. So the Vedic mathematics is from Vedas, from Vedic period, or the one where we use these formulae and get operations solved. So as far as these formulae are concerned, they can be applied wherever mathematics is there. So there is no special bifurcation as arithmetic, algebra, geometry, trigonometry, and various other branches. So here onwards we will be using some of the formulae. One of that is ekadikena purvena, meaning is by one more than the previous one. Second formula is ekanyunena purvena, by one less than the previous one. Another formula is Nikhilam Navatas Charamam Dashataha, that is last from 10 and others from 9. One more formula, vertical and crosswise in English and Urdhva Tiryakdhyam in Sanskrit. So like that there are so many formulae. Whenever we get some new formulae, later on we can add those formulae to our knowledge. So now from the beginning itself, a child starts writing the digits, or for him the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Indirectly he is using the formula ekadikena purvena, one more than the previous one. 1 plus 1 is 2, 2 plus 1 is 3, plus 1 plus 1 plus 1. That means 4 is one more than its previous 3. So indirectly he was using this formula but was unknown. If we enter into algebra, if x is a number, x plus 1 is nothing but ekadikena purvena, one more than its previous x. Then a child starts writing backward numbers. He writes from 9, 8, 7, 6, etc. And it is nothing but ekanyunena purvena, by one less than the previous one. For example, 7 is one less than its previous 8, or in general 1 less than x. So x plus 1 is ekadikena purvena, x minus 1 is ekanyunena purvena. If we add 1 to this 9, it is 10. So a maximum single digit, which is 9, when 1 is added, it becomes 10. Maximum double digit is 99. When 1 is added, 100. So minimum triple digit. Similarly, 999, 2000, and so on. So this 10, 100, 1000, 10,000, 1 lakh, or in general 10 to the power n is known as base. So when the number is near base, we can calculate various operations can be solved in no time, or mentally we can solve the problems. Now if you consider 9 and 10, so 9 is a maximum single digit, 10 is a minimum double digit. So what is known as puraka or complementary from 9 and complementary from 10, it plays very important role in mathematics. And this complementary from 9, so I will write C for complementary, 9 for complementary from 9, and C 10 means complementary from 10. So the meaning is when the sum of two digits 0 to 9, when it is 9, then it is known as complementary from 9. When the sum is 10, it is known as complementary from 10. Now 0 plus 9 is 9, 9 plus 0 is also 9. So 0 and 9 is known as complementary pair from 9. Other such pairs are 1 and 8, 2 and 7, 3 and 6, 4 and 5. All these 5 pairs are complementary from 9. 1 and 9 is 10, or 9 and 1 is 10. So it is a pair for complementary from 10. Similar such pairs C10 or complementary from 10 are 2 8, 3 7, 4 6, 5 5. So the knowledge of these complementary numbers from 9 and 10, how it is done, just we'll take one simple example. It is used, say, for subtraction from base or subbase. We have already seen what is base. Base is 10 to the power n. So 10 is a base, 100 is a base, 1000, 10,000, 1 lakh, 1 crore, and so on. It is a base. When we want to subtract some number from the base, say, what is the answer? So normally what we do, you borrow and then continue. It takes, say, half a minute or so, but directly we can write the answer as. This is where we use the formula Nikhilam Navatas Charamam Dashataha. Charamam means last, Dasha means 10. Last from 10, that means complementary from 10. 7 and 3, they are the complementary from 10. Nikhilam Navataha, others from 9. Others, means these are all other numbers from 9. 1 8, 5 4, 9 0, 8 1, 2 7, 3 6. They are the complements from 9. So just by writing, you start 9 9 9 9, last from 10. So 8 and 1 9, 0 and 9, and last from 10. Directly we can write such answers. Suppose this number is in lakh and we want to subtract 3 4 7. Now this 0, there are no numbers below this 0. So consider this as 0. And again use the same formula. 0 and 9, 0 and 9, 3, 6, 4, 5, last from 10. 99,653 is the answer. Now how we have subtracted from base any number. Similarly, we can subtract from what is known as subbase. So 10 is our first base, later on it is 100, next one is 1000. So between 10 and 100, other 10s, 20, 30, 40, 50, etc. After 100, between 100 and 1000, 200, all hundreds. After 1000, all thousands, and the list goes on. So all these are known as subbase. So now let us see how to subtract from subbase. 420,000 minus 3,859. So just have a two part just to understand. First part consisting of all zeros and second part consisting of a number. So this number is a subbase, and here two formulae are used. For this, as usual, nikilam namatas charamam dashataha, that is last from 10, others from 9. And for this, eka nyunena purvena, means one less than the previous one. So 42 minus 1 is 41, followed by last from 9, others from 10. So 3 and 6, 8 and 1, 5 and 4, 9 and 1, last from 10. The answer is 4161. So this number minus this number you have to carry out. For this 0, apply the same formula, last from 10, others from 9. Whatever difference is there, minus 1. Or here itself you reduce the number by 1. So 3 becomes 2. And then carry out the normal subtraction. This is 0, 4, 5. Followed by 9 and 10 complementary. Last from 10. One more Sanskrit word which we are dealing with frequently is known as Bijang. So Bij means seed and Ank means digit. So a seed digit in turn is single digit. So Bijang of a number is the converting any number into a single digit by adding all the digits in a number. Say suppose if 43 is a number, its Bijang key is 4 plus 3, 7. So 7 is the Bijang for 43. For 34 also it is 7. For 25 also it is 7. For 2, 3, 1, 2 plus 3 plus 1, it is 6. For 62, it is 8. 3 plus 4, 5. 3 plus 4, 7 plus 5, 12. 12 plus 2, 14. Means you are getting a double digit addition, which is 14. But it is not the Bijang because it has 2 digits. Again the answer, digits are added 1 and 4 to get 5. So suppose if the number is big 1, what is the Bijang of this number? Then we will be adding 6 plus 1 plus 2 plus 3 and so on to get the answer, but that is a time consuming method. That much time is also not required in Vedic mathematics. So how to find the Bijang of such numbers? So it is the special property of maximum number 9. Maximum single digit is 9. And the special property of this 9 is when you add or subtract 9 from any number, its Bijang remains same. So for example, if you take 14 as a number, Bijang is 5. 14 plus 9, 23. Its Bijang is 5. There is no change in Bijang even if we add 9. 14 minus 9, Bijang is So same is the case, whatever number you take, whether you take 11, Bijank is 2. 11 plus 9 is 20, Bijank is 2. 11 minus 9 is 2, Bijank is 2. So this 9, as far as Bijank is concerned, it acts like 0. So to any number, when you add 0 or subtract 0, number remains same. Likewise, when you add 9 or subtract 9, Bijank remains same. Now you use this property for finding out the Bijank quickly. Now here, how you have found the Bijank? 3 plus 4 plus 5 plus 2, which was 14. Then later on, 1 plus 4 is 5. So you have wasted the time, because suppose if you cancel 4 and 5, 9. In mind, whatever remained is 3 and 2. 3 plus 2 is 5. In this case, 6 and 3 is 9. 2 and 7 is 9. 1 and 8 is 9. What is left is 3 and 5, which is equal to 8. So directly you can find the Bijank of a number. So this is the easiest way to find the Bijank. Another method is that one is direct addition. Now second one, whenever while adding a number becomes 2 digit, there itself you convert it into Bijank, single digit. 6 plus 1, 7 plus 2, 9. 9 plus 3, 12. 12 is a double digit. 2 plus 1 is 3. Plus 7, 10. 10 means 1. 1 and 8, 9. 9 plus 3, 12 means 3 plus 5, 8. This is the second method. Now when one number is given, you are finding out its Bijank. What is the use of that? So it is used for Vedic check. You carry out various operations like addition, subtraction, multiplication, division, etc., etc. Whether your answer is right or wrong. How to check? So we'll start with addition. So this plus this plus this. First, this is the question. Your answer is, say 3 plus 2, 5. This is 3. This is 9. Whether this answer is right or wrong. So how much time is needed? Whatever time we have required for solving the example, almost same time will be needed, because we will be again doing 2 plus 3 is 5. This is 3, this is 9. Okay, I am right or wrong. Whereas by Bijank, it is very easy. I will show. Just find Bijank of each. So here it is 6. Here it is 5. Here it is 6. The Vedic formula Gunita Samuchayaha, it says that when a particular operation is carried out, to the numbers carry the same operation. If it is addition, carry addition, subtraction, subtraction to their Bijank. So here the Bijank of this number is this, and operation is addition. So what is the Bijank of question? 6 plus 5, 11 means 2, and 6, 8. So this is the Bijank of your question. What is the Bijank of answer? This 9 cancels, means 5 and 3, 8. So Bijank of question is same as Bijank of answer. So your answer is right. Suppose you have done some mistake. Instead of writing 3 plus 4, 7, 9, you have written 8. Some mistake you have done. Now, instead of 8 as Bijank, you will get 8 plus 3, 11 means 2 and 5. So, here it is 8, here it is 7. That means you have done some mistake. Now, where the mistake has been done, later on you can go for solving the actual exam. Subtraction. 1 minus 1, 0. 12 minus 3, 9. Carry over 1 and 1. 190 is the answer. Whether this answer is right or wrong. So find out the Bijank of the number. It is 7. It is 6. So the operation carried out is subtraction. So 7 minus 6 is 1. and the Bijank of answer cancelling 9 is also 1. That means your answer is correct. 645 minus 251. 5 minus 1 is 4. 14 minus 5 is 9 and 394 is the answer. Now let us check whether this answer is right or wrong. Bijank of this 4 and 5 cancels means 6. This 5 to 1 is 8. What is 6 minus 8? It is minus 2. And in Vedic mathematics this minus is 2 is written by giving a bar on top of the digit. Its value is bar 2. Now what is the Bijank of the answer? Cancel this 9. 4 plus 3 is 7. Now just see, one Bijank of question is minus 2 or bar 2, whereas Bijank of answer is 7. Whether it is different or same, just you will have to think. But both are same. How? One is negative Bijank, another is positive Bijank. Just we will write it here. One is bar 2, that is of question. For answer it is 7. Now you have seen earlier that when 9 is added or subtracted, there is no change in Bijank. So if I add 9 here, so 9 minus 2, it is 7, answer is also 7. So your answer is correct. Or if I subtract 9, question is bar 2, 7 minus 9 is also bar 2. Question and answer, the Bijanks are same, that means your answer is same. So whenever you get one Bijank positive, one Bijank negative, by adding 9 or subtracting 9, you make both the Bijanks positive or both the Bijanks negative and then check the answer. Multiplication. When we want to multiply 112 by 107, what is the answer? This is the answer, and let us check whether this answer is right or wrong. What is the Bijank of this? 4. Bijank of this 8. Operation is multiplication. So 4 into 8, 4 into 32. 32 means 3 plus 2, 5. It is the Bijank of question. What is the Bijank of answer? This 9 cancels, this 8 and 1 cancels, remaining is 1 and 4, which is 5. So Bijank of question is same as Bijank of answer. Squares. 65 square is how much? So whether this answer is right or wrong. So what is the Bijank of 65? 6 plus 5, 11. 11 means 2. Operation carried out is square. So 2 square is 4. It is the Bijank of question. What is the Bijank of answer? This 4 and 5, 9 cancels. Remaining 2 and 2, it is also 4. So the answer is correct. As far as cubes is concerned, what is 104 cube? So whether this answer is right or wrong. What is the Bijank of 104? 1 plus 0 plus 4 means 5. 5 cube is 125. 1 plus 2 plus 5 is 8. It is the Bijank of question. And what about answer? 8, 6 and 4. Because 6 and 3 is 9, remaining is 1 and 8. Cancels, remaining is 4 plus 2, 6 and 2, 8. So Bijank of question is same as Bijank of answer. So all these answers are correct. Now when remaining is division. In case of division, we will take a simple example and carry out the example first. So in this 2354 is known as dividend. We will denote it by E. E means dividend. 12 is the divisor. 196 is the quotient and 2 is remainder. So we know the equation. E means dividend is equal to divisor into quotient plus remainder. So for this example, it is 2354 is equal to D12 into 196 plus 2 is the remainder. So this is the equation we can build up from this example. Now we have to check whether the answer is right or wrong. Just see what is the Bijang. Bijang of left hand side must be equal to that of right hand side. So here 5 and 4 cancels. So 5 is the Bijang. 12 means 3. 9 cancels means 7. 7 3s are 21. 21 means 3 and plus 2. So 3 plus 2 is also 5. So our answer is right. So in this way we can check up by Vedic check various operations. So the same thing can be checked for algebra too. So here A and B, they are called the variables, and 2, 3 or here 4, 12, 9 etc. They are called the numerical coefficients. A, B, A square, AB, B square, they are called variables. So in case of algebra, we will be considering only numerical coefficient. So 2 here plus 3 means 2 plus 3 is 5. Don't consider A and B. So it is 5 square. 5 square is 25 and 25 means 7 is equal to 4 plus 12. 12 means 3. So 4 plus 3 is 7 and this 9 cancels. Even otherwise 4 plus 12 is 16. 16 means 7. 7 plus 9 is 16. Again 6 plus 1 is 7. So anyway, question Bijang is 7. Bijang of answer is also 7. So our answer is correct. So in this way you can check various examples, and all these things can be carried out only mentally. You need not have to write separately at the corner. Mentally just observe 2, 3, 5 square 25 means 7. This is 7. I am right, that's all. So in this way you can check various examples.